So now what we will do is, let us see what we have studied in the last class. So last class, what did we study? We took up chapter 1, and the chapter was matter in our surroundings. Okay. So I think Pratiksha, I spoke to Pratiksha last time. Priyadarshini, can you tell me what we studied last class from the beginning? First point, what did we study? Priyadarshini, can you unmute? What did we study last class? First point. Sorry, I can't hear. Okay, I'll help you. We studied what is matter, isn't it? Okay, I think Priyadarshini will go to Samiksha. Samiksha?
Yes, ma'am.
So what did we study last class?
We studied about physical nature of matter.
We studied about
Then
what is matter?
Physical nature of matter.
Okay. Physical properties of matter we studied. What was the first point we studied? We studied what is matter. What did we understand? Matter is all around us. Everything that we see is matter. I am also matter. So we saw that. And what did we say? What was the next point of matter?
And we studied
anything
about
which occupies mass and volume is called as matter.
Matter.
So matter will occupy space, and it has
mass.
It has mass. It has we can call it for time being as weight. So I occupy a particular space and I have a particular weight. So that is a property of matter. And then what else? Next point, what did we study? What is the difference between me and this mobile?
Mobile is a non-living thing.
Non-living thing, and you are alive.
You're the living thing.
Mobile is non-living, whereas I am living. Okay. Now, so your name is Pooja Ashok, isn't it? So what did what did we learn after that? We learned that our ancient Indian philosophers and as well as Greek philosophers. Yeah, Panchatantra or Panchatattva. All matter is made up of Panchatattva. Okay. Can someone tell me now what is this Panchatattva? What is it made up of? You raise your hand. Okay, I think Mahalakshmi. What is this Panchatattva made up of?
Ma'am, air, earth, fire, sky, and water.
Very good. So it is made up of these 5 elements, and this is a basic element for all the matter, whatever, whether it is living or non-living. Okay. Then in this chapter, the matter has 2 properties, like physical and chemical. Physical is what we see. For example, my hair. So you can say my hair is white, it is curly, it is short. That is what you see. But what is it made up of inside? It is made up of a protein. That protein is called keratin. So that protein, what is it made up of? How it is arranged? Why is it curly? Why is it straight? Why is it white? Why is it black? So that is a chemical nature. So today what we are, this first chapter deals with the physical properties of matter, what we see outside. Okay, so that is what we took up. So the physical nature of matter. So under that, what did we study? The first point. Anyone?
Matter is made up
Matter
of
is made up of
particles.
Matter is made up of small particles.
Pratiksha. Okay. Mahalakshmi's chance we got. Pratiksha, tell me, please. What is it? What is the physical nature of matter? What did we understand?
Ma'am, particles are having space between them. They are continuously moving and they are small in size.
Yeah, so we saw that the physical property of matter is, first of all, matter is made up of small particles. So small particles, and how small are the particles? How did we understand? We could not see. When I added sugar to water, you could not make out. But when I added Dettol to water, you could make out. It became cloudy, isn't it? So the cloudiness indicates that the particles, they're so small. And so that means matter is made up of very small particles. Finally, actually, there was people were thinking whether it is, initially they didn't know. See, now we know. At that time, they thought it was made up of big blocks. One group was saying it was made up of big blocks. Other group was saying it was made up of small particles. And with this experiment, that is with the Dettol, adding Dettol to water, we realized that it is made up of small particles. So that is the fundamental nature of matter. Matter is made up of small particles. Then what are its characteristics? So it has three characteristics. So first characteristic is, what is the first characteristic of matter? Now I'll ask Farhan.
Particles of matter have space
No,
between them.
no.
Particles are having space between them.
What is the, Farhan? What is the first
The
characteristic of?
particles having space between them.
Yes, very good. So particles have space between them. So how do we know particles have space between them? Again, the same experiment. So when the water has space between that, so sugar, salt will go and sit between the space. Dettol also will go and sit between the space. In case of Dettol experiment, we saw that. So that is the first, that is the first characteristic. Now, what is the second characteristic, Mahalakshmi? Mahalakshmi.
Particles of matter are continuously moving, ma'am.
They're continuously moving. Very good. So how did we understand that particles are continuously moving? We had these two experiments. So the first experiment, what is first experiment? Madhumita? For their
And
continuously
since when we look in a corner, we smell it. Sometimes it smell when we far.
Actually, another way of putting it is when we take, suppose incense stick, we'll have to keep it near the nose. Only then we can get the smell of the perfume there. But when we burn and keep it in the corner of the room, once you burn and you have to off the light, the smoke will, the smoke from there we can smell. We can from this we see smoke and then we get the smell of the incense stick. So why does this happen? I'll ask now Mahalakshmi. Why does burning of the incense stick or agarbatti
Because of the
stick,
diffusion, ma'am.
diffusion of what? Diffusion of what, Mahalakshmi? Very good. You're right. It is diffusion. Excellent. Now, diffusion of what is diffusing?
I'm intermixing of particles of two types of matter of their own, ma'am.
Yeah, so we are having intermixing of particles. See, actually, that they add incense stick, they add perfume. So that perfume will be present in that solid state. So when you burn, the perfume particles, they're actually gas. When you are burning, they'll become gas, and the gas will mix with air. And these gas particles will actually, they move. Their kinetic energy is more, and because of the heat, they move, and we are able to smell the perfume of the incense stick. Very good. So next, what was the next experiment we had? The particles are in continuous motion, which is the second experiment that we had to do. Okay, Madhumita.
Yes, ma'am.
Which is a second experiment to show that particles of particles in matter are continuously moving, which is a second experiment we thought we were that I told you to try at home.
So, ma'am, we take two beakers and we put one in one beaker we put honey, and another beaker we put a red ink or blue ink.
Very good. So we take water in a beaker.
And we
take two
and
beakers.
we do not stir it. We have to rest.
And you have to rest and we have to keep observing. Were you able to do this experiment, Mahalakshmi?
Yes, ma'am.
this second experiment. That is when we take water, add ink very carefully down the sides of the beaker. And in another beaker, we take water and add honey or jaggery. What does this experiment tell us?
Ma'am, ink spread uniformly, ma'am.
Very good. What about honey or jaggery? What will happen to honey or jaggery?
It's stored at the bottom.
It will remain at the bottom, but over a period of time, slowly the particles will, the honey particle or the jaggery particle will diffuse, and we will see a brown color. So that is so that indicates that when it is solid, it takes longer time for the particles to diffuse, isn't it?
Yes, ma'am.
Mahalakshmi?
Yes, ma'am.
Ma'am.
Yes, ma'am.
Okay. Now we will go to that. See, that was these two experiments, 1.4 and 1.5. It was to indicate that particles of matter are in continuous motion. Okay. So then we had another experiment, that is it was using potassium permanganate. So that potassium permanganate experiment, here there was a slight difference, where the difference lies in the fact that there was heating involved. So now let us just look at that particular experiment. So Sachin,
Yes.
yeah. Now you read the activity, that is 1.5 activity.
Yes, miss. Drop of crystals of copper sulfate or potassium permanganate into a glass of heat water and another containing cold water. Do not stir the solution. Allow the crystals to settle at the bottom. What do you observe just above the solid crystal in the glass? What happens as time passes? What does this suggest about the particles of solid and liquid? Does the rate of mixing change with temperature? Why and how?
Okay. So what is this? How do we do this experiment? Sachin, what we should do? Read what you have just now, go through again what you have read. What should we do? We should take what?
Miss one beaker, put it on copper sulfate or potassium permanganate and put it the hot water, not stir it.
Hmm. Yeah. So what
Just
we should do
observe
is,
the glass.
we have to just observe. Very good. So we have to observe that is how long it takes for the what happens when you are adding potassium permanganate crystal into hot water and into cold water. Okay, so we will do that experiment now. So I am having potassium permanganate. What it is, a powder form. It is not a crystal. Okay, so we will take hot water, cold water. So we will take about 100 ml of hot water and 100 ml of cold water. So I'm taking here cold water. Okay. So in a flask, I have hot water. So I'm adding hot water. You can see the water vapor, right? So I'm adding the hot water here. Then what I will do is I take potassium permanganate. This is a powder form. So it is not crystal. Crystal means we can see. Powder form, okay, it is still, we can have an idea about what happens. So I'm adding a small amount of potassium permanganate to cold water. So all of you can see.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, you can see that slowly the particles are diffusing. Okay. Now I will compare it with what happens when it is hot water. So I'm adding little less. Okay. Just see what happens. See, you can, let us see what is the difference between the two. Okay, we have taken little time for the hot to add the potassium permanganate into hot water. Can you see what is the difference? Any difference can you see here?
Ma'am, potassium permanganate in hot water is mixing fastly than cold water.
Yeah, you can see that diffusing fastly, it is entering into solution. Okay, so what is happening here from this? What do you understand?
Higher the temperature, higher the diffusion.
Very good. So heat has
Higher
helped
temperature, higher diffusion.
diffusion. Higher the temperature, higher the diffusion. So first of all, when I added solid into water, the solid particles, see the solid particles diffused into water. Okay, so there was intermixing of particles of solid with the particles of liquid. That is happening. That is because the solid particles, they have separated and they have diffused into the liquid particle. So this is this is a phenomenon that is observed in nature. This intermixing of particles of matter is called as, what is it called as, Farhan?
Diffusion, ma'am.
Diffusion.
It is called diffusion. Very good. So this intermixing is called diffusion, and diffusion occurs like faster when you are heating. Why does it occur faster when you are heating? I'll give Bhumika a chance. Bhumika?
Yes, ma'am.
Why does it happen? Why does diffusion occur faster when I'm taking hot water?
Kinetic energies move faster.
Yeah, this particles, this temperature will increase the kinetic energy of the particles. As a result of with that energy, because of that energy, they will move at a faster rate when compared to in cold water. This temperature will increase the kinetic energy of the particles, and after some time we can see that in this case in hot water they would have distributed evenly. Diffusion would have been it will be faster when compared to cold water, right? So this is the second property. And here see we have two states of matter. Potassium permanganate is what state? Is it a liquid state, solid state, or a gaseous state, Farhan?
Solid state.
Yes.
Solid
Yeah.
state. Solid state.
So, potassium permanganate is solid state and water is liquid state. So we had intermixing of the solid with the liquid state. Why? Because why does it happen? Why is this intermixing possible? In case of water, why is intermixing possible? Okay, now I think Naveen has the answer. Naveen, why this intermixing is possible?
In water, particles are space between them.
Very good, excellent. So particles of matter have space in between them, and so the solid will, and they're in constant motion. So the solid particles will separate, and then it will go into the space between the water molecules. So this is a second characteristic of matter. Now, what is the third characteristic of matter? We started last time. The third characteristic
Particles
of
of
matter is
matter attract each other.
Particles of matter.
Particles of matter attract each other.
very good. So particles of matter attract each other, which is one experiment we went through. What was the first experiment we went through? I think it was
Hindu mystery dance.
yeah. In the dance, we see that the girls are all holding each other very closely, and then we have another set. So we are having 4 groups of girls. So in first group, they're all holding each other very closely. Second group, what they are doing, they are holding their hands. And third group, what they are doing, Mantesh?
Touch their fingers
Touching each
only,
other.
ma'am.
They're just touching, very good. They're just touching their fingers. And the fourth group, what they'll try to do, they'll try to go in between them. So which group?
Try to run.
They'll try to run in between them. So which group do you think they can easily run?
Third group, ma'am.
Third group, ma'am.
Third group, they can. So why can, I mean, what is the reason they can go so easily in the third group?
Because it is so strong, ma'am.
Because no?
Because the space between them is very.
Because there is space between them, one. Secondly, that force with which they are holding each other, just touching. See, if you're holding, it will be like this. If you are just touching, the force between these two girls is very less. So you can break. Okay, so you can break. Whereas if you are holding the hands, it needs more energy. And if it is in the dance, means you need still more energy because they're holding each other so close. So if we consider the girls as particles, so the particles can have less force between them, they can have more force between them, or the force of attraction can be like it can be maximum, it can be less, it can vary. So that means that we can consider this as force of attraction between the particles of matter, right? Okay, so this so we had seen that first experiment. So we will go to the next experiment in that, just to understand. So this will help us in understanding about the different types of matter. So I think last class, I think we'll give Samiksha. Samiksha, read the next activity. I'll put it up.
Yes, ma'am. Take an iron nail, a piece of chalk, and a rubber band. Try breaking them by hammer, cutting, or stretching. In which of the above three sentences do you think the particles are held together with greater force?
Okay, very good. So what do you understand from this activity?
Ma'am, we should take iron nail and piece of chalk and rubber band, and we should try breaking them with a hammer and cutting and stretching. And then iron is having the greater force,
Hmm. Greatest strength.
and
Iron is having greatest. Very good. Yeah. Hmm.
and then the piece of chalk can be broken by cutting, and the rubber band can be stretched.
Yeah, a rubber band can be stretched, it can be cut. So if it is a rubber band, I can stretch the rubber band, I can cut the rubber band. So that is possible for the rubber band, in case of the rubber band. But in case of, I'll take up this one. If
Iron.
it is, yeah, iron. Okay, I will take up the spatula. So here I cannot cut it. I cannot cut this. Okay, because the particles are so closely held. Whereas in case of rubber band, I can cut with a scissor, I can cut. I can stretch, I can cut. That is, and see this one. If I do this, it will stretch. Of course, if I stretch too much, it will break, and after that, it regains its shape. Whereas in case of the spatula, I can't stretch. It will remain. It is rigid. It is retaining its space. The That is shape, right? Okay. Now, very good. Now we will go to Sanjana. Go to the next activity.
Yes, ma'am.
Hmm.
Open a water tap, trying breaking the stream of water with your fingers. Were you able to cut the stream of water? What could be the reason behind the stream of water remaining together?
Yeah. So, so what is this experiment? What do we do? What we can open a tap and then what do we do, Sanjana?
We have to open the tap and we have to try breaking the stream of water with
Hmm.
our fingers.
Hmm. Okay. So, see, have you ever done, if you have tap, water is there, have you placed your finger?
Yes, ma'am.
What do you observe?
Yes, ma'am.
What do you observe?
It will not cut, ma'am.
The stream again, it will join, isn't it? Okay. So this particles, so here, so that is in case of it, see, you keep a hand, maybe it will disperse, but after some time, again, it will come back in case of stream, the water in the tap. So this water state, what state is it? Whereas, see, in this case, it is a solid. Okay. This is a solid. But whereas in case of water, what state is it?
Liquid,
Liquid
ma'am.
state, ma'am.
It's a
Liquid,
liquid.
ma'am. Liquid, ma'am.
Liquid, ma'am.
Liquid. Yeah, very good. So what we have seen that these liquid particles, they have again force of attraction between them. They are continuously moving and there is space within them. Okay, so this is the this indicates a third characteristic of matter. So the first, yeah. So first was there is space, They're continuously moving, and the particles of matter
Attract
attract each other. If the attraction between the particles is more, then we have a solid particle. If the attraction between the particles is less than when in comparison, and if it is in a fluid, then we have a liquid. But if it is, I mean, and when it is, we cannot see. For example, we can smell the perfume of agarbatti that is in the gaseous state. So that, in other words, depending on the force of attraction between the particles, we have different states of matter. So the different states of matter are based on what?
The force of attraction
Attraction between the particles.
Force of
attraction
attraction.
between the force of
So they're
attraction
based
between.
on the, very good. They're based on the force of attraction between the particles. We have solid state, we have liquid state, and we have gaseous state.
Gas.
Gas. Okay. Now, I see whatever we have studied so far, we have seen that the particles, we see that they are intermixing on their own, and this process we call it as diffusion. Diffusion increases when temperature increases, and we see that in case of that experiment with agarbatti, so we could not smell that is the perfume in the agarbatti when it was cold, but when we lit it, and then through the smoke we could get the smell of agarbatti. That means the perfume in the agarbatti mixed with the that is air, and it moved and we could smell. So this gas we cannot see, but we can smell. Initially, when it is burning, you can see the smoke being formed. Now, this is a very important phenomenon in matter. See, like if you take up air, in air we are having carbon dioxide, we are having oxygen, and we take in air. So the oxygen that is present in air enters our body. The air enters, and oxygen will diffuse into our body, and then carbon dioxide comes out. Okay, so we are all living because of oxygen that is present in the air around us. So we have intermixing of one gas with another gas. Similarly, in nature, how do you think the animals that are animals that are present in water, inside water, no, there are fishes are living. Now, how do you think fishes are alive? They also need oxygen.
There.
Okay, Priyadarshini, you have raised your hands first. Okay, Priyadarshini, please answer.
In water, oxygen is dissolved so that aquatic animals can breathe.
Excellent. So there is intermixing of oxygen in water. That is, air also mixes with water, and this water that contains the oxygen, the aquatic animals are able to take it, and then that is how they survive. So there we are having mixing of a gas, oxygen, in water, whereas here we are having mixing of oxygen in a gas. So gas mixing, whereas there it is gas water mixing, isn't it? So there is intermixing of gas and water. Excellent. Okay, so this is what we have now. So this is a very important observation. Why? Whatever we see in nature, it is actually chemistry that is occurring. Say, for plants are taking in carbon dioxide, and then they are making food, and then they're giving out oxygen. We take oxygen and we are able to live. So see, we are having a relationship. We give out carbon dioxide. Plants, they take the carbon dioxide and they make glucose. They make food. We eat the food. See, the food maybe like it may be fruits, it can be grains. So this is a very important observation. This is a very important phenomenon that occurs. Right? All of you, any doubts?
No, ma'am. No, ma'am.
Very good. Okay. Now we'll go to the next one. That is, we will go to states of matter. So we have seen already, we have states of matter. We have 3 states of matter. What are the 3 states of matter, Shweta?
Solid, liquid, gases.
Solid,
Very
liquid, gaseous.
Yes, very good. Now, why do you? What is the difference between these three states? What is that? What is the difference between the three? All these three states of matter. Sneha.
Ma'am, can I
Ma'am, can I tell?
I can't. You put your hand, then I will. I can make out. Raise your hand, please. Okay. So I will. Whom should I ask now? Who was that? Who said? Priyadarshini asked. Somebody asked. Okay. Now what will I do? I will ask Shravan Kumar. Okay, Shravan Kumar. What is the difference between these three states of matter? What is the why we are having these three states of matter?
Solid have a definite shape, distincts, and boundaries, ma'am.
Mm.
Liquid have a no, it have fixed volume and it have no shape, ma'am,
Mm.
and no distinct boundary, ma'am.
Mm. Okay, and
gaseous have a no fixed shape, volume, and size, ma'am.
very good, very good. So solid.
Gaseous have a large space between them, the particles, ma'am.
Yes, very good. Mm.
Liquids have a space between them, the particles, greater compared to the solid, ma'am.
Very good.
And solid have a more less spaces between the present of the particles.
Very good. So in case of solid, what happens? The particles are so close together. So if you take them, this particular shape will be retained. So they have a definite shape, occupy a definite volume. That is because particles are very close together. So in case of a liquid, if I take a liquid, you see here it will occupy. I am taking 100 ml. So 100 ml will occupy this much space. But if I put it into a wider container, this 100 ml will go and occupy a particular shape of it will take the shape of the container, but the volume will remain the same. It will be 100 ml, but the shape will change. Okay, so and that means it is having a definite volume, but the shape changes with the shape of the container. And if I take gas, it occupies. It doesn't have definite as Shravan Kumar told. It doesn't have a definite shape. Doesn't have definite volume. It just spreads around, depending on the atmosphere. It just spreads, or depending on whatever is that the medium that is a matter that is around it. It will just spread. So these are the different states of matter. So we have now activities to understand this concept. Okay, so now I was Shweta. Shweta, did you read? Did I give you a chance to read? You read, yeah?
No, ma'am.
Now I think I will ask. Okay, Shweta, read the next experiment. That is 1.3.1 activity.
Collect the following articles: a pen, a book, a needle, and a piece of wooden stick. Sketch the shape of the above articles in a notebook by moving a pencil around them. Have a definite shape, distinct boundary, and a fixed value. What happens if they are hammered, pulled, or dropped? Are these capable of diffusion into each other? Try compressing them by applying force. Are you able to compress them?
Very good. Okay. So what did you understand from this activity, Shweta?
Solid have distinct boundaries and fixed values. They doesn't compressible when we go applying force on them.
Correct. So in this experiment, we are taking a chalk. Then what are we taking? We take chalk. Then
Ma'am, no chalk.
no chalk. What do we take?
No chalk, ma'am.
Okay, Shweta, what all we are taking?
A pen,
Uh,
a needle,
okay.
and a piece of wooden stick.
We take a book also. No book.
Yes, ma'am, book.
Book, and we take a piece of
A
wood.
needle of
We take a needle. We take a pen. We take a book and
a piece of wooden stick.
wooden stick. So all the four, if you draw, then you draw on a piece of paper, And you can see that they're having a definite shape and definite volume. Maybe if you take a wooden stick, you apply a lot of force, it may break. But if you're dropping the, say, pen, if I drop this pen, nothing will happen to this pen. If it is made up of glass, it will break. And if I'm dropping the book, nothing will happen to the book. Needle also, nothing will happen. That means the particles are so close together, they're strong, they're able to withstand the force. Maybe wooden stick. See, this I can't break, but wooden stick I can break. So this shows that, what does it show? The solid particles have, so what is the conclusion there?
The solid is very rigid.
Solid is very rigid, and
have fixed volume and distinct boundaries.
fixed shape and value.
Very good. So they have a
It
fixed
have
shape.
different shape, varium, distinct
They
boundaries.
are not
They are
capable
not
of
compressible.
They are not compressible. Very good. So that is the property of solids. They are not compressible. I can't compress the pen. Okay. So that is one. Okay. So next we will go to the next experiment. Shweta, Sneha. Sneha, read the next activity.
Yes, ma'am.
Unmute. Read from where Shweta left.
All of the above are examples of solids. We can observe that all these have a definite shape, distinct boundaries, and fixed volumes. That is, have a negligible compressibility. Solids have a tendency to maintain their shape when subjected to outside force. Solids may break under a force, but it is difficult to change their shape, so they are rigid. Consider the following. What about a rubber band? Can it change its shape on stretching? Is it a solid? What about sugar and salt? When are kept in a different jars, these take the shape of jar. Are they solid? What about the sponge? It is solid, yet we are able to compress it. Why? All of the above are solid, as a rubber band changes shape under a force and regains the same shape when the force is removed. If excessive force is applied, it breaks. The shape of each individual sugar or salt crystal remains fixed. Whether we take it in our hand, put it in a plate or in a jar, a sponge has a minute holes in which air is trapped. When we press it, the air is expelled out and we are able to compress it.
Very good. So what did we understand from this? What is this experiment first? So we are taking rubber band, then
Sugar and salt.
Sugar,
Sugar,
salt, and sponge.
Sponge
third
band.
is sponge.
Sponge.
All these are solids. Still, if you take this, so you first say rubber band. So rubber band, if I'm stretching, it is changing the shape. But when I'm removing the force that I've applied, it is regaining its shape. Okay. Now, if I'm taking sugar, the crystal, whether I'm putting it in a, if I'm putting it in a bottle or in a beaker, will the sugar crystal or the salt crystal, will it change the shape?
No, ma'am.
No, ma'am.
No, ma'am.
It will retain its shape, right? Okay. Now the third is sponge. So what happens to sponge when I press the sponge?
The air comes. The air is explode.
Yeah. So the sponge, when I'm pressing, if I press the sponge, it will contract. Okay, it will contract. But when I remove my hand, it will again go back to its original shape, isn't it? So what is a property? What is actually happening? Raise your hand. So one of you can raise your. I'll ask. Please raise your hand. What is happening in the sponge? In this experiment, when I press and this one, the relax the my hand. What is happening in the sponge? Okay, I can't see any hand. So I will ask Sneha itself. So what is happening, Sneha?
Yes, ma'am.
In the sponge, when sponge is having a. You've seen a sponge, Sneha?
Yes, ma'am.
Okay. When I press the sponge, what will happen?
It will compress, ma'am.
It will compress. Very good. It will compress. And then when I remove my hand, it will go back to its original shape. Why does this happen?
Ma'am, can I?
Who is it?
Yes,
Because it
Priyadarshini.
contains holes, ma'am.
Okay.
Ma'am, it
contains
contain
pores.
gas.
It contains
it
pores.
contains
It
gas,
contains
ma'am.
pores.
Gas.
And in the
With
holes,
air
there is
flow,
gas.
ma'am.
Air is present
It
in the
contains
holes.
holes, and in that holes, it contains gas, ma'am.
It contains gas, correct. So it has number of holes. In that holes, air is sitting there. So when I press this air, I will be driving out the air, isn't it? So when I relax, again air will go and sit, and the sponge will come back to its original shape. Okay, so here we are seeing that again. When we say, even though we are saying solid, the solids have different properties. Rubber band is having one type of property. Then we are seeing that the crystals, I mean, it can withstand a particular force. In case of sugar and salt, it retains its shape, and in case of when air is present, it is compressible, isn't it? So very good, Sneha. Next, Spurti. Read, continue. Next, from where Sneha left.
Collect the following: water, cooking oil, milk, juice, a cold drink, containers of different shapes. Put a 50 ml mark on these containers using a measuring cylinder from the laboratory. What will happen if these liquids are spilled on the floor? Measure 50 ml of any one liquid and transfer it into different containers one by one. Does the volume remain the same? Does the shape of the liquid remain the same? When you pour the liquid from one container to other, does it flow easily?
Good, very good. Okay. So first question I'll ask you. So you're taking milk, oil, water, maybe you take, and when you spill it into the floor, what happens? Does it have any definite shape?
No, ma'am.
No, ma'am.
No, ma'am.
Yeah, it just spreads. If you add water, it will just spread, isn't it? Now, if you are adding it into say different containers. So if you are taking, let us take up a big glass, or you take a plate, then it will take the shape of that particular container, isn't it? Have you ever seen that? You can try at home. You
Yes.
can take the water in a glass, then you can pour it in a plate. In a glass, it will occupy a particular space in the glass. In a plate, if you see, it will just spread, isn't it? Yes
Yes,
or
ma'am.
no?
Yes, ma'am.
Yes.
Yes, ma'am. Yes,
Very
ma'am.
good. Yeah. Now, what is the third observation we have to do? Are we able to pour water? We are always able to pour water, isn't it? It is fluid. I'm able to pour water. The third thing is it is easy. The water is fluid. We can pour water. This is the observation of a liquid. Okay. So now, so this again indicates the property of a liquid. Liquid will take the shape of the container. It doesn't have a definite shape. It takes the shape of the container. Third is it is fluid. It can be poured. Whereas solid, I cannot pour. No, solid, it will sit like this. Whereas liquid, I can pour. So we have seen the three different properties of a liquid. Very good, Spurti. So next person, continue from.
Can I read, ma'am?
Yeah, please, Sujata, read.
We observe that liquids have a no fixed shape but have a fixed volume. They take up the shape of the container in which they are kept. Liquids flow and change shape, so they are not a rigid but can be called fluid. Refer to activities 1.4 and 1.5, where we saw that solids and liquids can diffuse into liquids. The gases from the atmosphere diffuse and dissolve in the water. These gases, especially oxygen and carbon dioxide, are essential for the survival of aquatic animals and plants. All living creatures need to breathe for survival.
The aquatic animals can be breathed under the water due to the presence of dissolved oxygen in the water. Thus, we may conclude that solids, liquids, and gaseous can diffuse into liquids. The rate of diffusion of liquids is higher than that of solid. This is due to the fact that in the liquid state, particles move freely and have a greater space between each other as compared to particles in the solid state.
Very good. So, what did we understand, Sujata, from what you read? What did you understand from the beginning?
Liquids having no definite shape. It's have a only definite volume.
Volume.
This is not a rigid. It is another name is fluid. Aquatic animals survive in a presence of water.
Presence of in water,
Presence
because why do this?
oxygen.
Yeah, oxygen is
Present in the water.
Oxygen is present in water. Oxygen has diffused in water. Actually, air has diffused in water. So this air or the oxygen present in air has diffused in water, and that oxygen the animals make use of. Very good. And including us, we make use of, as we discuss, air that is present. Air contains oxygen. We are taking that oxygen, and that is how we are surviving. Okay. Now, one point I said that liquids, they don't have a definite shape. They occupy the shape of the container, and they are fluid in state. And another important point is their volume remains the same. See, the 50 ml that I add, whether it is into a plate or into another vessel, the volume is the same. Only the shape is changing. Shape is changing from one form to another form. And I am able to pour. That is, it is fluid in nature. And they were referring to experiment 1.4 and 1.5. Which is that? Which are those experiments? When Sujata read, no, she said,
It is about
which is that?
honey and ink, copper sulfate, and potassium permanganate.
In solid and liquid dissolve in water.
Very good. So that 1.4, 1.5 refers to that experiment where we did that. No, we added salt, we added sugar to water. Then we didn't have that day. I didn't have potassium permanganate. I added Dettol. No, you could see it became very cloudy. So there we saw the intermixing of that is a solid with a what?
Liquid.
With a liquid. Very good. And agarbatti experiment was what? That activity with agarbatti, no? Burning. What is it?
Particles of continuous
Continuous motion. Very good. And another point, now that we know matter, it is another, it also indicates another point. What is that? Okay, I'll give a hint. It is having agarbatti is having perfume, and it's perfumes.
It do not have fixed volume and shape.
Which one? Gas. Yes, gas does not have fixed volume and state. Now, what I want you to tell me is, if we, like, let us say, think in agarbatti and burning agarbatti and getting the smell. I'm burning agarbatti somewhere. I'm getting the smell. So what is happening? The perfume in agarbatti, it is diffusing. When I'm burning, it is diffusing, and I'm able to smell far away. So the particles of the perfume have moved. They have gone to the gas, and then I'm able to smell. I'm not able to see the smell. So it is an example of intermixing of what?
Two different types of matter.
Two different type of things.
Two different types of matter.
It is two. Is it two different types of matter? Saying, okay, yeah, we can consider it as two different because agarbatti is solid. Okay, air is liquid. Air is a gaseous, this one. So from the solid state, it has moved to the gaseous state. We can consider like that. Now suppose I say this air is having oxygen. Okay, and oxygen is one, air is one. So it is intermixing of which two types of matter? Is it two types of matter or is it
Gaseous.
only one? Gaseous. So here it is intermixing
Gaseous
of
matter.
two gas. Yes,
Gaseous.
it is. Oxygen is also a gas, air is also a gas. So it is intermixing of gases.
Sugar.
It is intermixing of gas. Whereas this is an intermixing of solid in water. Isn't it? Intermixing of solid in water. Now suppose I add the water to another water, it will be intermixing of, if I am adding the water, potassium permanganate water into
Liquid
another
and liquid.
Liquid and liquid.
Liquid.
Excellent. So it is liquid and liquid. So air we can't see, liquid we can see, and solid solid we don't know what is happening inside. In solid we can see only what is outside, isn't it? So we don't know what is happening, but and it is no, it is not possible because the particles are so closely arranged. The force of attraction is so much that there is no intermixing possible. Okay. Okay. So thus, to conclude today, we have studied the three important characteristic of that is we have. Yes. Any doubts? Yeah.
Ma'am, I have one doubt, ma'am.
Yeah. What is it? Who is it?
Ma'am,
I
water
can't see.
also. Ma'am,
Who is it?
Mahalakshmi.
Mahalakshmi. Yeah. What is that doubt, Mahalakshmi?
Ma'am, water also contain oxygen, ma'am. Why we can't breathe in water, ma'am?
See, in our case, no. See, in our lungs, no, they are not made for like that. See, in case of aquatic animals like fishes and all, no, they have what is called gills. So they are able to take that through the gills. No, water is able to enter. When water enters, oxygen also will enter. They'll take only the oxygen and give away the rest of the water. So whereas our lungs, no, when I'm breathing water, the whole water will enter my lung, and my lung cannot function. See, if you see, our lung is made in such a way that air can go, and actually we have small, tiny branches called alveoli, and actually alveoli, below the alveoli there is blood. So oxygen that is present in the gas will diffuse into this blood that is present in the thin membrane. Okay, so we don't have the ability. God has not given us the ability. Okay, whereas let us take up aquatic plants. They have that ability to take out the oxygen from the water. They have that ability, whereas we don't have the ability. Very good question, Mahalakshmi. Did I answer? Did you understand? Mahalakshmi, is your doubt clear?
Yes, ma'am.
So because of how God has designed us. Okay. Any other question? Very good question. Any other? Okay.
Ma'am, I am a question.
Ask. Who is it? I can't make out.
Ma'am,
who is it? First of all, tell, because I cannot make out. No, who is it?
Farhan, ma'am.
Farhan. Farhan, ask me.
Ma'am, why we do not take nitrogen and other gases?
See, our body, how it is designed is we'll take oxygen. See, when we say we are taking oxygen, actually, like, we, for example, I can give an example. When we buy, when we want to buy, let us take up milk, we give rupee, we give rupees and we buy milk. We give five rupees, we take some amount of, say, a small glass of milk, whatever it is. So in our body, the currency is it is a chemical. Okay. Now that chemical, what will happen is that chemical will break. It is called as ATP. I'm just giving a short form ATP that will break to ADP and what is called as inorganic phosphate. When it breaks, some energy is released. That energy is used. See, in our body, it is like a chemical factory. Okay, when I take food, from the food, like digestion happens, glucose will enter into glucose. Then from fats, we have this fatty acids, proteins, all of them will enter into our body. Into each of them have different components. Let us take up glucose. Glucose will give you energy. Why do I say glucose will give energy? Glucose will go through a set of chemical reactions. Okay, when it goes through the set of chemical reaction, energy is released. That energy is obtained from this breaking of ATP to ADP. Okay. Now, how does this ATP have energy? That is happening because of this oxygen molecule. So in our body, it's such a wonderful factory. this oxygen will move through what is called, it is called as an electron transport chain. It is like moving from one molecule to another molecule to another molecule. During that process, no, ATP will be formed. That is, money is being formed. And then that money, that ATP, that energy stored in ATP is used to convert, say, glucose to, I'm moving my hand. So a lot of energy is required. So now ATP would have broken down to ADP. This formation occurs because of this oxygen, characteristic of oxygen. And you know what happens is oxygen will combine with hydrogen and form water molecule. So you do a lot of exercise, you'll start sweating, a lot of heat is generated and water is formed. So this actually oxygen is its characteristic is such a way that slowly it will move. Lot of energy is generated. That energy is taken, made into what is this currency, rupees like ATP, and that is used for our activity. See, for me to teach, I need energy. That energy is obtained from ATP. That is obtained from glucose. But for to drive that reaction, we are having this ATP form, and for that to form, we need oxygen. It's actually very beautiful. If you really understand how your body is functioning, you will understand that your body is such a extraordinarily, perfect machine. There's no wastage. We men, I mean, human beings, we have tried to make so many machines, but still, there will always be some wastage. See, if you are making a car, means it is releasing a lot of fumes into the atmosphere, a lot of carbon dioxide into the atmosphere. Whereas in our body is so designed that we are living out carbon dioxide. Carbon dioxide is used by the plants to make food. We eat that food. So, so that it is to answer your question, it is a property of oxygen that is making us survive. Good question, Farhan. You understood? Did I help you to understand?
Yes, ma'am.
Very good.
Ma'am, ATP, adenosine triphosphate. No, ma'am.
Yes, excellent. Yes, adenosine triphosphate. Excellent. You have studied about that? Huh?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Very good. You studied how did ATP get formed? Adenosine triphosphate. How is it formed?
By oxidative method, ma'am.
Yes, it is formed by oxidative method. When ADP, adenosine diphosphate, combines with an organic phosphate, it forms ATP, triphosphate, diphosphate, triphosphate. And for that for that energy that is for this reaction, no energy is required. That is obtained from the electron transport chain. You have read about that?
No,
Electron
ma'am.
transport.
No, ma'am.
No, ma'am.
You studied about mitochondria.
Yes,
Yes,
ma'am.
ma'am.
It is
Yes,
a
ma'am.
yes, ma'am.
Very good. So mitochondria, this oxidation takes place. That you must have studied, isn't it?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes, very good. So mitochondria, no, the structure, if you see, it is having one characteristic structure. So there, all this part, it is a chain. They will be sitting there one by one. They'll be sitting, and they'll pass oxygen from one, that is one molecule to the next molecule to the next molecule. They'll be passing. So during that time, the energy is released, and one ATP is formed. So actually, if I remember right, I think from one glucose, I think 3 molecules of ATP. Once next time when I come, I'll tell you how many molecules of ATP we get from one glucose molecule. Okay,
Yes,
and
ma'am.
okay, very good question. Okay, any other doubts?
Ma'am, I have a doubt.
Okay, who is it? I can't see. That is why. Who is
Prerna,
it?
ma'am.
Prerna.
Prerna.
What is the doubt?
Ma'am, I want to know how does the water fluff in the clouds, whereas water is a liquid and cloud is a gaseous thing.
Very good, excellent. See what happens, when we take. See when because see there is water present, sunlight falls on it, so water will, from the liquid state, it will go to the gaseous state. Okay, so we are going to study that next. That is called evaporation. So it will go into the gaseous state, and this gaseous state, as we know, these particles, they move. So they just continuously move on top as the water evaporates, and this gas moves. It moves up. That means you imagine a large amount of gas water gas is moving up and it is forming the cloud. So the energy from the sun converts liquid water to gaseous water. So that means there is change in state of water. From a liquid stage, it can go to a gaseous state also. So did I answer? Did you understand?
Yes, ma'am.
Oh, very good. Any other good question? All of you are asking very good questions. I'm very happy. Any other question? No doubts. Okay. So what we will do, I'll summarize. See, we have learned a very important, what we call as phenomenon in these two classes. One is diffusion. That is very important. That is particles, they intermix in nature. And this natural mixing is called as diffusion. And then we have also studied about the particles of inherent energy, kinetic energy of the particles. No, they inherently move that with the help of, they inherently have a kinetic energy of motion because of which they're continuously moving depending on the type of matter. Okay, that is another important, aspect that we have learned. Then what we have studied studied the three characteristics of matter. What is the three characteristics of matter, Pooja?
Can I say, ma'am?
No, I want Pooja to answer. I want Pooja only to answer. Pooja, can you answer?
Yes, ma'am.
What are
Particles of matter have space between them. Particles of matter are continuously moving. Particles of matter attract each other.
Excellent. So this we studied, and then this we started last class. This class we went through it again. Now then we studied about states of matter. So we studied that there are three states of matter. Okay, who will answer? Okay, Madhumita.
Yes, ma'am.
Can I
The
tell?
solid state and liquid state and gaseous state.
Liquid state and gas.
We studied solid state, liquid state, and gaseous state. Okay, so with this, what actually, if you see, now it is time up. Okay, what we can do is, who was the last to answer? Who read last?
Sujata, ma'am.
Sujata. Okay, after Sujata, Sahana, just go through the questions there. I think we'll not take more time. After what Sujata read, no, there are some questions. Just go through the questions, Sahana.
Yes, ma'am. Have you ever observed a balloon seller filling a large number of balloons from a single cylinder of gas? Inquire from him how many balloons is he able to fill from one cylinder. Ask him which gas does he have in the cylinder.
Okay, right. Right. Okay. So that is he from the cylinder is transferring the gas into balloons, right? Okay. Next, what is okay? So this point is, what is he doing? He is transferring a glass from one container into another container. Okay. Next, read. Another minute will take. Sana, continue, please.
An activity, ma'am.
No, I think okay, because I can't see the textbook. Okay, what we will do, we'll stop today. I wanted to, there are some questions at the end that we will start in the next class. We will answer the questions. We have been discussing, we all know that, and we will answer the questions that are there in the textbook next class. Okay, students? So very good. I'm very happy. We had a very nice class. I'm very happy with your interaction. Thank you, students. Thank you, children.
Thank you. Bye, ma'am.
Bye.
Bye,
See you
ma'am.
next week, students. Okay, see you.
Okay, ma'am. Bye, ma'am.
Bye.
Bye, ma'am.
Bye.